Okay, so here's help on problem number one on the review. They ask you to solve this using the quadratic formula, and what makes this tough is they want you to write it as an exact answer. So, well, first thing we're going to notice is this is not written in the correct order. So we're going to go ahead and write it in the correct order first. I'm going to write this as 0 is equal to negative 5v squared plus 5v plus 1. Notice that now it is in the correct order. However, if you start solving it like this, right, and you say a is equal to negative 5, b is equal to 5, and c is equal to 1, remember, I'm going to be using the quadratic formula here. So I need my a, b, and c. But if I start doing this the way it's written right now, I'm going to run into a lot of negative simplifying issues. So instead of doing this, I'm going to go ahead and swing everything over to the left. That way, this number right here, this becomes a positive. It's always easier when that leading term is positive. So I'm going to go ahead and swing everything over by adding 5b squared to both sides, by subtracting 5b to both sides, and by subtracting 1 to both sides. And when I do that, it pretty much switches the signs on everything. So I get 5v squared minus 5v minus 1 is equal to 0. Now this is going to make it a lot easier to use my quadratic formula where my a is 5, my b is negative 5, and my c is negative 1. Okay, so that's the first part. Second part, let's go ahead and start using the quadratic formula. So I'm going to go ahead and start replacing my values. I get x equals negative parentheses negative 5 plus or minus the square root of, I'm going to substitute my b, so that's a negative 5 squared, minus 4 times my a is 5 and my c is negative 1, all over 2 times a, my a is 5. Okay, so then this becomes 5 plus or minus the square root of, negative 5 times negative 5 is a positive 25. I see that there are two negatives here, and so that's going to turn this into a positive, so I'm actually going to be adding. And then 4 times 5 times 1 becomes 20 all over 10. That's x equals 5 plus or minus the square root of 45 divided by 10. Now, this looks like it would be a perfect answer, but remember, if you can simplify your radicals, you really should. So let me go ahead and simplify the radical. That square root of 45, I'm going to do this off to the side. Square root of 45 actually has 9 in it, right? And 9 is a perfect square. So instead of writing, I don't know the square root of 45, but I know 45 is the same thing as 9 times 5, and I do know the square root of 9. That's why I'm writing it like this, is because I was able to rewrite the 45 so that I can take the square root of something inside that 45. I know the square root of 45 is the square root of 9 times 5. I know the square root of 9 is just 3. So I know the square root of 9, it's 3. I still don't know the square root of 5, so I'm going to leave it as square root of 5. So this becomes x equals 5 plus or minus 3 times the square root of 5 over 10. Okay, so this is going to be the correct answers. You're going to write both answers. That means the first answer is going to be 5 plus 3 rad 5 over 10. And the other one's going to be 5 minus 3 rad 5 over 10. Or you can switch the order. It doesn't really matter. Those are your two answers. One of the things I've noticed is sometimes you guys try to simplify when you can't. And then sometimes you don't simplify when you should. So let's pretend right now, I know a lot of you guys would look at that 5 and look at that 10 and be like, oh, I can divide both of them by 5. And that's true. But when you simplify these fractions, you need to be able to simplify everything. So this 5, this 3, and this 10 do not share anything that can be simplified. So you cannot simplify this fraction, okay? Later on, you're going to get problems where you can. So let's do a little other mini example. So again, this answer is done, okay? But let's give you a different example. Let's say, like on the next one, you're going to get something that maybe looks like this. Okay, let's see what simplifies. Well, look, this has a 5, this has a 5, this also has a 5. I can divide everything by 5. And when I do that, I'm going to get 1 plus or minus 1 square root of, man, I shouldn't have picked 4, huh? Let's do 7. All over, if I take the 10 and divide it by 5, I get 2. So you see how this time I was able to simplify because all of these simplified, this one, and this one together, okay? So you simplify all of them. The other thing I want you to notice is, hey, you see that 1 square root of 7? Because it's 1, you don't need to write it. So you could just write this as 1 plus or minus the square root of 7 over 2.